Alright, so for 41, we have two fractions with different denominators, so we need to add, get a common denominator, which is the product of this and this, and add the fractions together. So you guys know that for in order for us to get a 0, the numerator has to equal 0, right? So that's what we're looking for. Okay, so be careful because you've got x's and y's and it's really easy to get confused and write the right thing, and that messes you up for the rest of the problem. So just be careful. So I'm going to multiply this one times this one to get, to add the fractions together to get a common denominator. So it's going to be, let me just write it out like this first. So cosine x minus cosine y times cosine x plus cosine y. I'm going to do the same thing for the next fraction, plus sine x minus sine y times sine x plus sine y. So that is all over the product of sine x plus sine y times cosine x plus cosine y. So I'm going to leave the denominator as is. I'm going to concentrate on the numerator because remember the goal is to get 0. So as soon as we get 0 in the numerator, that's it. That's what we're looking for. So distribute the first two terms, the first two factors. So that gives me cosine squared x plus cosine x cosine y minus cosine x cosine y minus cosine squared y. Okay? Now I'm going to move on to do the same thing with the sine factors. So that's going to be plus sine squared x plus sine x sine y minus sine x sine y, I'm running out of room, minus sine squared x. And the denominator, sine squared y. See what I mean? You gotta be careful. The denominator, I'm just gonna write this down. I'm gonna leave it this way. The next step, cancel any terms that cancel out that give you 0. So cosine x minus that one, and then this one and this one. Okay? So now I'm gonna rewrite them. Rewrite what's left. So I've got cosine squared x minus cosine squared y plus sine squared x minus sine squared y all over the denominator. Okay? So notice, and I'm gonna draw lines. If I get these together and I get these together, okay, I'm gonna have, for the first one, it's gonna be cosine squared x plus sine squared x. The other one's going to be minus cosine squared y minus sine squared y. That's sine squared right there. All over the same denominator, the LCD. So this one right here equals 1. And this second one, when you factor out the negative 1, also gives you 1. So it's going to be 1 minus 1 over the denominator, the LCD. So that's going to be 0 over the LCD, which is 0. Alright, so for 43, the strategy that's going to help us get from one fraction to two terms is by multiplying numerator and denominator by the conjugate of the denominator. So let me write out the left side first. So I'm going to multiply this by 1, okay, but the 1 is going to look like this, okay, like that. So now I have, I'll leave the numerator factored out for now, sine theta, the denominator becomes 1 minus sine squared theta. And you know that 1 minus sine squared theta equals cosine squared theta. And so I got 1 plus sine, cosine squared theta. So then I can reduce this, 1 cosine in the numerator and 1 cosine in the denominator. And now I have this fraction here. I'm going to separate it like this. Remember, you can do this with fractions, right? So 1 over cosine is secant, and sine over cosine is tangent. And that's it. For 45, we're using the cofunction identity. So sine squared of pi over 2 minus x is cosine squared of x. Bring down the sine squared of x, and so this equals 1. And that one's done. Number 47 has a typo in the book. They have an x right here, so just get rid of it and write it like this. So I'm going to bring down the sine x and multiply it by the cofunction of cosecant, which is secant, and then that's x. So sine x times secant x is sine x times 1 over cosine x, which is sine over cosine, which is tangent. And that's it. Okay, I'm skipping 49 and 51 because those were part of the previous homework. Number 42, B42. Okay, so I'm skipping over to 53. So your goal here is to get cosecant. I'm going to convert these to sines and cosines. So secant is 1 over cosine theta. Cotangent is cosine over sine theta. So I'm going to cosine over cosine reduces to 1. And so you have 1 over sine theta, which equals cosecant theta. Okay, done. Alright, for 55, I'm going to add the two fractions, so I need a common denominator. So the first fraction gets multiplied by 1 plus sine theta, so let me just write it out. 1 plus sine theta times 1 plus sine theta. The second fraction gets multiplied by cosine theta, all over, and I'm going to leave the denominator in factored form for now, because one of the factors may cancel eventually. Okay, so I'm going to leave it like this for now. So now I have distributive property on the first two factors, so 1 plus 2 sine theta plus sine squared theta. And then this is plus cosine squared theta, right? Cosine times cosine. All over cosine theta times 1 plus sine theta. So I see right here that this equals 1. Right? So 1, and then I have a 1 right here. So 1 plus 1 is 2. So I get 2 plus 2 sine theta over cosine theta times 1 plus sine theta. Okay, so I'm going to factor out a 2 in the numerator. And so that gives me 2, 1 plus sine theta over cosine theta times 1 plus sine theta. So I notice the factors 1 plus sine theta are common in both numerator and denominator, so I cancel those out. That gives you 1. And so you're left with 2 over cosine theta, which is 2 secant theta. And that's what you needed. Alright, so on 57, both sides are equally complex or simple. So there's no one side that, would be better or better to work on. So I'm going to stick with the left side. Okay, the left-hand side. So I'm going to multiply the denominator and numerator by the conjugate of the denominator. So I've got sine beta. Again, remember, that's one of the strategies. Whenever you see 1 plus or minus a function, and there's nothing else you can think of to do to get it to look like the other side, multiply by its conjugate. Okay, so conjugate is 1 plus cosine beta. over 1 plus cosine beta. Okay, so in the numerator, I'm going to keep it factored, and the reason why is because I noticed that my goal has this as the numerator, and see how I have it right here? So I'm going to find a way of saying, of canceling, getting rid of that. Okay, so right now I'm going to write it in factored form, like this, over, and the denominator is 1 minus, because when you distribute, when you multiply right here and here, you get 1 minus cosine squared beta. And we know that cosine squared beta is sine squared beta. So sine B, sine beta. Again, Pythagorean identity, right? So sine squared beta. And so 1 sine beta cancels with 1 sine beta in the denominator. And that's exactly what the right hand side looks like. 1 plus cosine beta over sine beta. Alright, so the key to the next 3 problems is factoring. So I'm going to work on the right hand side this time to make it look like the left hand side. So right here I notice that both of them have cotangent to the 4th x in common. So I'm going to write cotangent to the 4th x, and that's cosecant squared x minus 1. Well, cosecant squared x minus 1 equals, let me just write down the 4th right here, equals cotangent squared x. And when you multiply those together, you get cotangent to the 6th x, which is exactly what you needed. Alright, so I'm going to take what's inside the parentheses and factor out the greatest common factor. So I'm looking at these two guys right here. So I'm going to factor out a tangent squared, so let me put brackets because it's still inside the parentheses, tangent squared x, and then when you do that you get 1 plus tangent squared x, okay, secant squared x, and I know that this is secant squared x, so I'm going to bring this one down, tangent squared x, and then this is secant squared x, and then we have on the outside secant squared x. So these two get multiplied together and you get tangent squared x times secant to the 4th x. And just to make them look exactly the same, we just switch the order. And you are done. Alright, so again I'm going to work on the right side, and I'm going to do the same thing I did on 72, where I took the greatest common factor of these two terms, which is sine squared x. So that leaves me with 1 minus sine squared x. And then on the outside I've got cosine x. Okay? This one gets replaced with cosine squared x. So I bring down the sine squared x times cosine squared x. And on the outside I've got cosine x. Multiply those together. Sine squared x times cosine cubed x. And then just switch them so it looks exactly the same. So cosine cubed x times sine squared x. And that's it.